I'm interested in the formation of precipitation in clouds. I knew that I wanted to study meteorology probably from the time I was maybe in 3rd or 4th grade. I used to wait for the weather to come on the news at 10 o'clock every night. That led me into making measurements on aircraft, and I came to the University of Wyoming and began working with the King Air. At that point, I knew I wanted to be somebody that looked at the physics of clouds.
Now, French wants more details on the processes that allow ice crystal formation in clouds and the conditions favoring them. Cloud ice is a prerequisite for rain or snow.
Recent conditions in the West, in terms of droughts and increasing demands on water supply and decreasing supplies of snowpack in the mountain, coupled with the potential for a changing climate, has caused water managers to take a second look at cloud seeding. Do we know if we can modify clouds to the point that we can produce precipitation and have it fall to the ground due to silver iodide? The answer is now yes.
During the winter of 2017, French, other scientists, and the Idaho Power Company collaborated on a project called SNOWY, or Seeded and Natural Orographic Wintertime Clouds, the Idaho Experiment.
It was the first time ever anyone has demonstrated from the input of silver iodide into the cloud all the way through to precipitation fallout to the surface. We were able to make measurements over the entire course of the evolution of the cloud particles and the precipitation in the cloud. Really, the more important question is, can we produce enough water or precipitation to make a difference? We don't know the answer to that yet. For it to be useful to the general public and to water managers and to state and local governments, they need to know whether we can produce more precipitation, leading to more snowpack. And if so, how much and under what conditions can it be effective so that it can be used as a tool? And that's what our research hopes to address in the coming years.
Data gathered during some 23 snowy flights includes measurements of cloud particle sizes, concentrations, and shapes, along with temperature and humidity.
So we have a lot of flights to analyze, to characterize the clouds, both in natural conditions as well as in regions that were impacted by cloud seeding. Following on with that is utilizing those measurements in the numerical cloud models that are currently being run on the Cheyenne supercomputer. This work will continue for the next 4 to 5 years before we hopefully reach the final answer of how effective the cloud seeding was in the mountains of southwest Idaho during snow.